Okay, let's jump right in. Today we're doing a deep dive into estimation, specifically how you'd even start figuring out the number of hotels in a big city like Bangalore.
Yeah, it sounds kind of impossible at first, right? We've got these listener notes detailing an exercise just like this.
Exactly. So our mission is to unpack that logic, see what assumptions they made, and how they landed on a number.
It's really about the thinking behind it, less about nailing one perfect number.
So what number did this exercise come up with? Spoilers allowed here.
Okay. The estimate lands somewhere around 800 hotels for Bangalore.
800. Okay. How do you possibly get there from nothing?
Well, the main approach in these notes is area-based. You start with the known quantity, the total size of Bangalore.
Which is about, what, 600 square kilometers, roughly?
Yeah, around 600 kilometers,
Yeah.
but obviously that's not all potential hotel space.
Right. You've got lakes, parks, big residential areas, roads, loads of places you wouldn't build one.
Exactly. So the next step is a big assumption. What chunk of that is actually, suitable? The note suggests maybe 50%.
50%. So cut the 600 down to about 300 square kilometers of usable land.
That's the idea. Factoring out the big unsuitable chunks, leave you with 300 kilometers to work with.
Okay, 300. Still a huge area. How do you populate that with hotels? You can't just sprinkle them evenly.
Right. So the method then divides that 300 based on assumed hotel density. Like you'd expect more hotels downtown than way out in the suburbs.
Makes sense. Different zones.
Yep. They split it into three rough categories. First, about 25% of that suitable area, so 75 kilometers on, is tagged as highly dense.
And for that zone, they assume.
An assumption of 5 hotels per square kilometer. Think prime business districts, major tourist hubs.
Okay, 75 times 5. That's 375 hotels just in those core areas.
Correct. Then, the biggest chunk, 50% of the suitable area, about 150 kilometers, gets labeled mid-dense.
Lower density there, I assume.
Yeah, they figure maybe 2.5 hotels per square kilometer, kind of your main commercial roads, established neighborhoods outside the very center.
Let's see, 150 times 2.5. It's another 375 hotels. Same number as the high density bit.
Yeah, it's just how the assumptions on area and density worked out in this case. Interesting coincidence.
Okay, so what's left? The last 25%.
Right, the final 25%, another 75 kilometer, is the low dense zone. More residential, maybe newer areas.
And the density assumption there must be pretty low.
Much lower, only 0.5 hotels per square kilometer.
So 75 times 0.5, that adds just 35 hotels.
Exactly, so you add them up. 375 plus 375 plus 35.
Comes out to 785 hotels using that whole area and density breakdown. Pretty close to the 800 estimate.
That's the area methods result, but the notes actually include a second approach, almost like a sanity check.
Oh, interesting. From a different angle entirely.
Totally different. This one's based on population and sort of tourism demand.
Okay, how does that work? Bangalore's population is huge, right? Like 15 million.
Yeah, 1.5 crore or 15 million people. The thinking is hotel demand is driven by people visitors, business travel, maybe even locals needing temporary spots.
So population is a kind of proxy for how many people might need a room.
Sort of. The key assumption here is estimating what fraction of that population base might represent daily hotel room demand. The notes use a rough figure, like maybe 1 in 1,000 people.
1 in 1,000 of 15 million? Hang on. That's 15,000 potential room nights needed per day?
That's the number generated by that assumption, yeah? It's a way to anchor the demand side.
Okay, 15,000 rooms needed. But hotels vary wildly in size. How do you get to a number of hotels?
Another assumption needed. The notes use an average hotel size of about 20 rooms, trying to balance out the big chains and the smaller guest houses.
Got it. So 15,000 rooms needed, divided by an average of 20 rooms per hotel.
Gives you about 750 hotels.
Wow. Okay, so the area method gave us around 785, and this population demand method gives us 700 entry.
Exactly. And that's the powerful part, isn't it? Two completely different ways of thinking about the problem, using different data, different assumptions.
And they land in roughly the same ballpark. It makes that final estimate of around 800 feel much more solid.
It really does. It shows you can tackle these huge, seemingly unmeasurable things by breaking them down logically and checking your work from another angle.
So the core insight is using different proxies area, population making reasonable guesses, and seeing if the results converge.
Precisely, which gets us back to that estimate of roughly 800 hotels.
Yeah.
But it does leave you with a thought, doesn't it? How much difference would a small change make? Like, what if only 40% of the land was suitable? Or what if the average hotel size was 25 rooms, not 20?
Right. How sensitive is the final number to those initial guesses?
Exactly. And maybe think about what other things in your daily life seem impossible to count, but perhaps you could estimate them using a similar breakdown. Something to chew on.